In this video, we're going to talk about the ideal gas law. The ideal gas law is obviously for ideal gases, but as we've discussed in the introduction video, that ideal gases follow the kinetic molecular theory, and we don't have to worry too much as long as our temperature is relatively high and our volume is relatively large as well. So, what is the ideal gas law? The ideal gas law is going to relate all the four properties of the gases: pressure, volume, number of moles, and temperature into a single equation. This is PV equals nRT, or the perv-nerded equation, because it looks like the word perv-nerd. Now, R. What is R? R is the universal gas constant. Remember when we were doing PV equals K, and P over T is equal to a K, and N over V is equal to a K, not N over V, V over N is equal to a K. All those different things where we had the K, and I said not to worry about those Ks. Well, if we combine all those Ks up, we get the universal gas constant. And so there are two values in the universal gas constant. There is, if you are in atmospheres, R is equal to 0.0821 liter atmospheres per mole Kelvin. It's a very unwieldy unit, but it's very important that you remember that it's liter atmospheres per mole Kelvin. If your pressure is in millimeters of mercury, you're dealing with 62.4 liters times millimeters of mercury over moles Kelvin. What I really suggest is memorize one, the one I'm circling here. Know that and make sure that all of your other units are in liters, atmospheres, moles, and Kelvin. You only need to know the one. That will get you through. Let's do an example of the perv-nerded equation. How many moles of a gas are contained in a typical human breath that takes in 0.50 liters of air at 1 atmosphere of pressure and 37 degrees C? So what have I got? I've got my pressure, I've got a volume, number of moles, R, and T. The pressure is 1.0 atmospheres. The volume is equal to 0.50 liters. The number of moles is what I'm looking for. R is a constant, 0.0821 liter atmospheres per mole Kelvin. And the temperature is 37 degrees C. But remember, anytime we have a temperature, we got to turn it into kelvins. So add 273, and that gives us 310 Kelvin. So PV equals nRT. I want to find N, so I'm going to divide both sides by RT. So PV over RT is equal to N. And I can plug in my numbers here. Pressure is 1.0 atmospheres. And my volume is 0.50 liters over 0.0821 liter atmospheres per mole Kelvin times the 310 Kelvin. Now watch our units here. Atmospheres, atmospheres, liters, liters, Kelvin, Kelvin. I get 1 over moles, which means that the moles goes on top. So we get N is in moles. That's a good thing. And when we do the math, we get 0.020 moles of gas inhaled. Now, this is a simple PV equals nRT problem. We can do all sorts of stoichiometry using PV equals nRT, and we will see some of those examples a little bit later in the examples video. Now, from here, you should move on to the next video, which will be Dalton's Law. And Dalton's Law is a really important law because it deals with mixtures of gases.